Well, with this problem, it's not going to take any fancy trig identities. We're just going to plow through the algebra first, add 3 to both sides. 4 cosine squared of 2 theta is equal to a 3, and then divide by 4. And now take the square root, but keep in mind that when you take square root, it can be positive or negative the square root. So cosine of 2 theta is equal to plus or minus, and then the square root of 3 will stay square root of 3, but square root of 4 is a 2. And then because this is a 2 theta, we're actually going to get twice as many answers as usual. And because we have to consider the positive and the negative, we're going to get twice as many answers as usual. So if this just said cosine of an x, and that said a positive square root of 3, then that would mean that we're going to get 2 solutions. Because of this, double it, 4 solutions. And then because it's positive and negative, double it, probably 8 solutions. So this is on the face of it saying, take a look at the cosine graph, and just the regular cosine graph. Don't worry about 2 theta until later. So here's the regular cosine graph. And then when is it equal to the square root of 3 over 2? And we'll use the calculator to get one solution, which looks like it's just a little bit smaller than pi over 2. And then after that, we'll use the calculator to get sine inverse of the negative square root of 3 over 2. If you go over here, that looks like it's just to the right of pi over 2. And so we've got cosine inverse of a square root, cosine inverse of a square root of 3 divided by 2. That looks like it's, well, let's see, divide by pi, change to a fraction, is pi over 6. So we've got, this one is at pi over 6. And then do the same thing with a negative, so insert a negative square root of 3 over 2, and it's how many? So divide by pi, and convert that to a fraction, is 5 pi over 6. And then if we continue at a height of radical 3 over 2, then that's going to say there's another solution right here, just to the right of 3 pi over 2. I think I need to start writing some of these down. So 2 theta is equal to pi over 6. And then I can get this one over here, which is going to be 3 pi over 2. So that one's going to take place at 3 pi over 2. And then because of the symmetry, this one is going from, let's see, this one is going from where it was at a height of 1, and then you go over to right here, that's pi over 6. So I should say when it was at a height of 1, 2 pi, then go over by pi over 6. So instead of using this, I should be using 2 pi, go to the left by pi over 6. That's going to be 12 pi over 6 minus 1, 11 pi over 6. And that is what 2 theta is equal to. Now these two solutions come from this line up here, so that's coming from the positive square root of 3 over 2. And then from the negative square root of 3 over 2, we've got 2 theta equals this one, 5 pi over 6, which is saying, okay, I started right here, which is when the function is at its highest, and then go over by 5 pi over 6. And so if we continued over, there's going to be another solution right here, which is saying from when the function was at its highest, 2 pi, then go over by 5 pi over 6. So that's going to be, take a 2 pi and go over to the left by 5 pi over 6. So subtract 5 pi over 6. And then this is going to be 12 of them minus 5 of them equals 7 pi over 6. So we've got over here 2 theta equals 7 pi over 6. There's 4 of the solutions. Actually, they're going to be divided by 2 at the end. So this one would actually be pi over 12 and 11 pi over 12. Before I continue and get the other 4 solutions, I think I want to take a look at the graph. So y equals 4 cosine of 2x squared minus 3. And then when does that equal 0? 1, 2, 3, 4, 5, 6, 7, 8 times. And the first one that I would be getting is pi over 12. So trace and see if this first one is pi over 12. Pi divided by 12 is correct. And I think this would be the next one, which would be 5 pi over 12. 5 pi divided by 12 is the next one. And then 7 pi divided by 12. And this one would be 11 pi divided by 12. Okay, so it looks like I'm on the right track. Now to get these other 4 solutions, I need to take these guys, before they were divided by 2, take these guys and add 2 pi. So then, if you take those guys, and then to all of them, I'm going to add 2 pi. Add 2 pi. So it's going to be 2 theta equals, 2 theta equals, so 2 pi, since I need the fraction 6, is going to be 12 pi over 6. So add a 12 pi over 6 to all these. So if you add 12 pi's to 1 pi, that's going to be 13 pi over 6. 13 pi divided by 12. Once we divide it by 2, okay. And then add 12 pi to this, and it's going to be 23 pi over 6. This one, add 12, is going to be 17 pi over 6. And this one will be a 19 pi over 6. And then all of them should be divided by 2. Let me just check that one real quick. If I divide by 2, it's going to be 17 pi over 12. 17 pi over 12 is correct. Okay, so then I've got, here's all 8 of them. Pi divided by 12. Next would be 5 pi divided by 12. And 7 pi divided by 12. And 11 pi divided by 12. That's those first original 4. And then these guys, 13 pi divided by 12. 17 pi divided by 12. 19 pi divided by 12. And 23 pi divided by 12. Wow. 8 times the fun